So for solution to question number 5, we go this way. We write Q equal to IT. Q equal to IT. That is, we want to know the quantity of electricity that flows when a current of 0.5 ampere is used for 3 hours. When a current of 0.5 ampere is used for 3 hours. Therefore, Q will be equal to 0.5 ampere times, you open bracket, 3 times 60 times 60, you close the bracket, seconds. So that gives you 5,400 coulombs. That gives you 5,400 coulombs. Now, we go to the equation because this is a divalent element. So we write M2 plus 2E minus, M2 plus 2E minus gives me M solid, meaning that 2 Faradays will be required to discharge 1 mole of this element we are talking about. 2 Faradays will be required. And these 2 Faradays, we write it is equal to 2 times 96,500 coulombs, which is 193,000 coulombs, which is 193,000 coulombs. So we write 5,400 coulombs of electricity. That's 5,500 coulombs discharge 1.79 grams. Coulombs discharge 1.79 grams of M. Therefore, 193,000 coulombs. Therefore, 193,000 coulombs we discharge. 193,000 coulombs we discharge. 5 we discharge. Do I go ahead? 193,000 coulombs over 5,400 coulombs. 193,000 coulombs over 5,400 coulombs times 1.79 grams over 1 times 1.79 grams over 1. So we can now use our calculator. Use your calculator and see what it looks like. Okay. You should remember that anything that is discharged by 193,000 coulombs, which is 2 Faradays, is equivalent to 1 mole of this element M, because the element M is a divalent, meaning that 2 Faradays is responsible for the discharge of 1 mole. So anything that this 193,000 coulomb discharges, that is the molar mass of this metal. And we should also know that for metals, their molar mass is equal to their relative atomic mass, only that the latter has no units. So whatever we get now, whatever we get now will be the what do you call it? Whatever we get now will be the relative atomic mass of metal M. Whatever we get now will be the relative atomic mass. Okay, Tiberia. So, whatever 193,000 coulomb discharges will be equivalent to the relative atomic mass or the molar mass of this metal X. And what is the answer?
The answer will be 63.98
grams,
grams,
which is equivalent to 64 grams. So the relative atomic mass of the metal in question is 64 grams. Because whatever 2 Faraday discharges is the relative atomic mass of the metal, because 2 Faradays is equivalent to 193,000 coulombs. And these 2 Faradays got from the fact that 2 moles of electrons were involved in its discharge. Okay, go together.